Welcome to Science Tuition Academy. In this GCSE chemistry lesson, we will be learning about atoms, elements, and compounds. Now, as we are starting the GCSE chemistry course, it is vital that we go through these 5 key words. They are atoms, molecules, elements, compounds, and chemical bonds. Now, we will be using these words a lot on the GCSE chemistry course, but unfortunately, students often do not use them correctly. Now, don't worry, we will be learning about these terms during this lesson. The best students will have a very good grasp of these key words. Now, here's a quick warm-up activity for you to try, which I call the do now. There's 3 questions. Pause the video now, and once you've had a go, hit play and we'll go through the answers together. All right, then, hopefully you've had a chance to complete those questions. Let's go through the answers. So question 1, name the particles that all substances are made of. The answer is atoms. Question 2, the periodic table has 2 types of elements. One type are the metals. What are the other types of elements called in the periodic table? The answer is non-metals. Question 3, give the chemical formula for water. Suggest the chemical formula for carbon dioxide. So the first part of that question, the chemical formula for water is H2O. And the second part, suggest the chemical formula for carbon dioxide. The chemical formula is CO2. Now, substances and atoms. Now, in everyday life, we use a lot of materials, and there's some examples of some of the materials that we use, such as cardboard, glass, plastic, paper, rubber. Now, all substances are made of atoms, and there are around 100 different types of atoms that exist. Now, here is a definition, the first definition that we must learn for an atom. So, an atom is the smallest part of an element that can exist. Now, with regards to definitions, we do say to all our students that it's best to write these down on a separate revision card. And we would also suggest that you only use our definitions. Please do not use the ones on the internet because they are often incorrect. Now, atoms at this stage, we just want all of our students to think of atoms as solid spheres. Now, they are very, very small and we cannot see them with our naked eyes. Now, one thing to remember is that atoms, yes, they are very, very small, but they do vary in size. You will get smaller atoms and bigger atoms. So the smallest atom is actually hydrogen, and a bigger atom would be something like iron. Now, we know there are 100 different types of atom. Now, each type of atom will have its own chemical name and its own chemical symbol. Now, here are some examples of these different types of atom. So you've got chlorine, carbon, nitrogen, hydrogen, and oxygen. So those are the names, the chemical names. And each atom will be slightly different. Each atom or type of atom will also have its own chemical symbol. So chlorine has the chemical symbol capital C, lowercase l, Cl. Now, some chemical symbols will be slightly different and they won't match their names. So Na is the chemical symbol for sodium, and we'll do a little bit more work on this in a few slides time. Now, here is a discussion activity for all of you to try. So this is on the particle model of matter. So the particle model of matter shows how atoms are arranged to make solids, liquids, and gases. Please see diagrams below. So you got 3 diagrams, A, B, and C. There are 3 questions. So please now pause the video, and once you've had a go, hit play, and we'll go through the answers. Okay, time to check the answers. So box A. So the first question was identify which box shows a solid, liquid, and a gas. So box A shows us a gas. Box B shows us a solid, and box C shows us a liquid. The next question was describe the arrangement and the movement of the particles in each box. So let's look at box A. Now in box A, we can see the particles are far apart and move randomly in all directions. For box B, the particles are tightly packed in a regular arrangement. You can see the regular rows or layers, and only vibrate in fixed positions. So they cannot move around and swap positions, but they can vibrate in their fixed positions. For box C, the particles are close together and arranged randomly, which can move past each other. The third question was describe the strength of the forces of attraction between the particles in each box. So for box A, the forces of attraction are very weak or negligible, and we can tell from the particle diagram because the particles are far apart. For box B, the forces of attraction are very strong, which keeps them all in a fixed position. And for box C, the forces of attraction are weaker than in solids because the particles can move, but they are stronger than gases because the particles are close together. Now, this is our second definition that we must learn. So, what are elements? So, an element is a substance that only contains one type of atom, which are found in the periodic table. Now, we've got three examples of elements here. So, let's look at the first one, copper. Now, copper is an element because all of the atoms in copper are the same type. There's just one type. They are all copper atoms. So therefore, copper is an element. Carbon is also an element because all of the atoms in carbon are carbon atoms. So they are one type, the same type. And helium is also an element because all of the atoms in helium are helium atoms. Again, one type, the same type. So therefore, it's an element. And because these are elements, they will be found in the periodic table. Now, here is a picture of the periodic table. We know that the periodic table contains all the elements, and we know that there are 100 different types of element. Now, elements can be very simple and consist of just single atoms that do not bond with other atoms. So, for example, if we look at this here, the elements in this column, which we call group 0, all exist as single atoms. Some elements come in pairs of atoms to make molecules. We are going to do some work on molecules. And these elements in group 7, this column here, they all come in pairs of atoms. Some elements are made up of large number of atoms to form what we call giant lattice structures. So the elements can be very different from one another, but the most important thing is an element must have the same type, the one type of atom. And you can see it here, all the atoms are the same type. These two atoms are the same type. And obviously, if you've only got one atom, it can only be one type. Molecules. Now, this is our third definition that we must learn. So, a molecule is a particle that consists of two or more atoms chemically bonded together. So, elements can be found as atoms or molecules. So, here, if we look at this diagram here, elements can be found as atoms. So, here you've got single atoms. And again, you've got a group of atoms, same type, but they are not chemically bonded together. So, some elements are just single atoms. However, the majority of elements actually have atoms that are bonded together to form what we call molecules. If we look at the first molecule here, we can see that there are 4 atoms that are chemically bonded together to make a molecule of 4 atoms. This is still an element because all of the atoms are of the same type. This molecule is made up of 8 atoms bonded together. As all the atoms are identical, the same type, this is still an element. And here we've got a simple molecule of just 2 atoms bonded together. And again, as the atoms are the same type, this is still an element. So elements can be atoms or they can be molecules at this stage. So just to emphasize the point, so again, we've got 4 examples of elements. So the first 3 are molecules because you've got more than one atom bonded together. The last one is just an atom, which obviously is an element. It doesn't matter how many atoms are bonded together, so long as there's only one type of atom. And that ensures that we have elements. So this is an element, that's an element, that's an element. And obviously one atom will always be an element. Here's a quick quiz for you to complete as a progress check. Simply look at the particle and then tell me if it's an atom or a molecule. If you want to pause the video, you can, and just hit play when you're ready for the answers. So the first one is just a simple atom on its own. So this can only be an atom. Nice and simple to start with. Question 2. Well, this particle is made up of 2 atoms that are chemically bonded together. This black line is a chemical bond. So therefore, this has to be a molecule made up of 2 atoms. So this is a molecule. Question 3. This particle, we can see, has 8 atoms, and these lines represent chemical bonds. So these atoms are bonded together. So therefore, this now is a molecule, and we can say that this is a molecule made up of 8 atoms. Question 4. Now, the particles here are a little bit more trickier than the previous ones. So we've got these single atoms here that are not bonded to any other atom. So we definitely have atoms here, but we've also got these particles here that are bonded, where we've got 2 atoms bonded together. So these are molecules. So we've actually got both. We've actually got atoms and molecules in this example. Okay, so just to recap the definitions of atoms and molecules. So an atom is the smallest part of an element that can exist. And a molecule is a particle that consists of 2 or more atoms chemically bonded together. Here's another quick quiz for you to complete as a progress check. So this time it's a fill in the gaps. Please read each statement carefully and work out what the missing word is. So pause the video now, and once you've had a go, hit play and we'll go through the answers together. All right, then, hopefully you've had a chance to complete those questions. So question 1, a substance that contains only one type of atom is called an element. Question 2, there are around 100 different types of element in the periodic table. Question 3, the smallest particle of an element that can exist is an atom. Question 4, gold is a substance that is an element because it only contains gold atoms. Question 5, elements can be made up of single atoms or many atoms chemically bonded together to form molecules. Okay, then. So metals and non-metals. Now, we've had a look at the periodic table, and we know that all the elements are shown in the periodic table. And we know there are 100 different types of atoms, so therefore there are 100 different types of elements. Now, we also need to be able to identify the elements as metals or non-metals. So the elements are split into two types. And what we use is this staircase here. And you do need to learn where this staircase is, because this will help you in the exam to identify where the metals are and where the non-metals are. Okay, so please learn this staircase. And we can clearly see that there are a lot more metals, okay, on the left hand side of the periodic table than non-metals. Now, the first 20 elements are very important. Now, all GCSE students must be able to use the names and chemical symbols of the first 20 elements in the periodic table. Now, the first element is hydrogen in the periodic table. Then it's helium. Then we go down to lithium, beryllium, boron, carbon, and then on to sodium. And then we finish at calcium. Now, you will be given a periodic table in all of your exams. Now, chemical symbols. Now, chemical symbols are used to represent the elements, and they are very convenient for us to use. They save us a lot of time rather than just writing the chemical names of the elements. So the symbol for most elements will just simply use the first letter of the name. So for example, hydrogen starts with H and its chemical symbol therefore is a capital H. Now, it's very important that you use capital letters as the first letter in the chemical symbol. Now, some elements will have two letters in their chemical symbol, such as lithium. The first letter will always be capital L. Okay, so a capital letter. And the second letter here we can see is a lowercase. And again, for aluminium, it's got two letters in its chemical symbol, capital letter first, followed by a lowercase letter. Now, some elements will have strange chemical symbols, such as lead. Now, a lot of students will say, sir, why do we have PB for lead when it starts with L? Well, the answer to that is that some of these chemical symbols come from the Latin names. So lead, its Latin name is actually plumbum, and that's why we use PB. So the chemical symbol comes from the Latin name rather than the English name. Gold is called aurum in Latin. So it's very, very important now we learn these two simple rules for writing chemical symbols, because too often students lose marks because they don't write chemical symbols correctly. So the two rules are as follows. The first letter of an element symbol is always a capital letter. So for hydrogen, it's going to be capital H, not lowercase h. The second rule is if there are two letters in the element symbol, the second letter is always lowercase. So for example, nickel has capital N, lowercase I. Now, if we didn't do this and we wrote capital N and capital I, this would actually mean that there are two elements here, which would actually now not mean nickel, it would mean nitrogen and iodine, which is totally different to nickel. So we have to be very, very careful when writing chemical symbols. Now, here's another quick quiz for you to complete as a progress check. Okay, so 7 questions. Pause the video now, and once you've had a go, hit play and we'll go through the answers together. Okay, time to check your answers. So question 1, what are all substances made up of? The answer is atoms. Question 2, how many different types of atoms are there? 100. Question 3, what do we call substances made up of only one type of atom? Elements. Question 4, how many different types of elements are there? 100. Question 5, where are all the elements shown? Periodic table. Question 6, what can we use instead of names to represent the elements? Chemical symbols. Question 7, what are the two types of elements shown in the periodic table? Metals and non-metals. Hopefully you found that okay. Let's move on. Now, there's a really good question here. How is it possible to have so many different substances when there are only 100 different elements or 100 different types of atom? Now, we have millions of substances on our planet. And how can we make them when we only have 100 different types of atom? Well, the answer to that is we can actually combine the elements in different combinations to make new substances, which we call compounds. Now, elements can react with other elements through chemical reactions. I am going to give you a definition for compounds on the next slide. Now, we can also separate compounds back into the elements by doing another chemical reaction. So chemical reactions are very important if we want elements to combine and make new substances. So here's our fourth definition now for a compound. So compounds are substances that contain two or more different elements chemically bonded together in fixed proportions. So let's have a look at water now. We can see that water, this molecule, has two different types of atoms bonded together. We've got hydrogen atoms bonded to an oxygen atom. Whenever we have this, we now do not have an element, we have a compound because it's made up of different types of atom. This is still a molecule because we know what a molecule is. Any particle that has two or more atoms bonded together will form a molecule. Now, carbon dioxide here is also a compound because we have different types of atoms. So we've got carbon atoms bonding to oxygen atoms, different types of atoms bonded together. So this is a compound. These are both molecules though, because they have more than one atom bonded together. So elements and compounds. So most of our substances are made up of different types of atoms bonded together. And the two popular examples to use are water and carbon dioxide. Both are molecules, but these molecules contain different types of atoms or different elements bonded together. So therefore, these are now classified as compounds. Okay, so let's just reinforce and consolidate our understanding of compounds and link them with elements. So here we've got some particle diagrams and we can see that these two atoms, they're the same type. So we've got hydrogen, which is an element. We've also got oxygen made up of two atoms. And again, this is an element and they are both molecules because they are made up of more than one atom. When these react, so remember when elements react, they undergo chemical reactions and we have now made a new substance. And this molecule now is made up of different types of atom bonded together. So water now is a compound. And this is how we make lots and lots of different materials on our planet. Now, the other thing is that the elements will have often very different properties to the compounds that are produced. Now, we know what the periodic table is. We know it contains all the elements. We know that the elements They are split into metals and non-metals. There are 100 different types of elements. And we know that the elements now can undergo chemical reactions to form compounds. Remember, compounds are never found in the periodic table, only elements. Now, let's briefly just talk about properties. So, at this stage, we just need you to know that elements, the properties of the elements, will be often different to the properties of the compounds that are produced. So, carbon here we can see is a black solid, and oxygen is a colorless gas that is quite reactive. When these two react, they produce carbon dioxide, which is a compound, and this is also a colorless gas, but a lot less reactive than oxygen. So we can see that the properties have changed. When we make water, which is a compound, from the elements hydrogen, oxygen, again, the properties of the compound produced, water, are going to be very different to the properties of the elements that the water has come from. So here you can see hydrogen and oxygen are both colorless gases, very reactive, and they produce this liquid that is quite unreactive and stable. Okay, so let's recap the definitions for elements and compounds. So an element is a substance that only contains one type of atom and are found in the periodic table. And if we look at the particle diagrams here, we can see that for oxygen, the particles, the atoms are the same type, one type. So this is an element, and it's the same for nitrogen too. Now, compounds are substances that contain two or more different elements chemically bonded together in fixed proportions. And again, if we look at the particle diagrams, we can see that water has different types of atoms bonded together. So does carbon dioxide. Now, I just want to emphasize this point here, together in fixed proportions. What this means is that all compounds will always have the same fixed proportion. So for water, water will always have two hydrogen atoms to every one oxygen atom. That's what we mean by fixed proportions. And carbon dioxide will always have one carbon to every two oxygen atoms bonded together. And again, that's what we mean by fixed proportions. So here are some examples of compounds, and we can clearly see from the particle diagrams that the atoms that are bonded together are different. So these are all compounds. Now here's a quick quiz for you to complete as another progress check. So simply look at the particle and tell me if it's an element or a compound. So this is question one. If you want to, you can pause the video and hit play when you're ready to go. Okay, this first one, well, the atoms are bonded together. They are the same type. So this is definitely an element. Question two. Okay, we've got four different atoms here, and we've got two different types of atoms bonded together. So you've got nitrogen atom bonded to these hydrogen atoms. So therefore, as we have different types of atoms bonded together, this has to be a compound. Question three. Okay, so this shows us that all the atoms are bonded together. So this molecule is made up of four atoms of the same type, one type. So therefore, this is definitely an element. Question four. Okay, so all of the atoms here, we can see they are bonded together. There's only one type of atom, so this has to be an element. Question five. This molecule has quite a few atoms bonded together. Now, there are different types of atoms. We've got the yellow atom in the middle. We've got the red atoms. There's 4 red atoms. And we've also got the white atoms. So there are 3 different types of atom chemically bonded together. So this has to be a compound. So we can say that this is made up of 3 different types of atom or 3 different elements. So this is a compound. Okay, question 6. Okay, this question's trickier than the previous questions. Let's go through the answer. So here we've got these molecules here, water molecules, and we can see that they are made up of different types of atom. So we've definitely got compounds here, and we've also got these molecules which are made up of different types of atoms. So these are compounds, and these compounds are not bonded to one another. You've also got these hydrogen atoms are bonded together. So these are elements because they're the same type of atom. And you've also got this oxygen that should be bonded together. Okay, same type. So here we've actually got elements and compounds. Okay, so you've actually got 2 different types of element. You've got hydrogen and oxygen. And you've also got 2 different types of compounds, water and carbon dioxide. So just to recap then, so we should now know what atoms and molecules are and to use those words correctly. So an atom on its own obviously is also an element, yeah. So atom, if you have atoms that are bonded to other atoms, then we form molecules. So this is a molecule of 2 atoms, a molecule of 3 atoms. Okay, they can be the same type or different type. Elements and compounds. So if you've only got one atom, it has to be an element. If you've got more than one atom bonded together, but as long as they're the same type, one type, then we have elements. And then compounds when you have different types of atoms bonded together. So atoms, molecules, elements, and compounds. Now here's another discussion activity for you to try. So the boxes below show different substances. Have a go at those 4 questions. So pause the video now, and once you've had a go, hit play, and we'll go through the answers. Okay, time to check your answers. So now, which boxes show elements? Well, box A, you've got the single green atoms, so that has to be an element. And you've also got these red atoms that are bonded together, and that's also another element. So we've actually got 2 different types of elements. So box A definitely shows elements, 2 different types of elements. Box B does not show any elements because this molecule is made up of 2 different types of atom. Box C also shows an element because you've got the same type of atoms. Question 2, identify which boxes have compounds in them and explain why. Well, we've already said before, box B is the only box that shows a compound because these molecules have different types of atoms bonded together, which means that it's a compound. Question 3, how many elements is the compound made up of? Well, box B is the only one that has a compound, so like we said before. And there's 2 different types of atoms. There's the red ones and then the green ones. So there's only 2 different types of element that make up this compound. Last question, question 4. Identify which boxes contain a mixture and explain why. We will be doing more work on mixtures, but a mixture is just 2 or more different substances not chemically bonded together. Here we've only got one substance, so that cannot be a mixture. Here we've only got one substance because we've got one compound. But here in box A, we've actually got 2 different substances that are not chemically bonded together. So can you see the green atoms are not bonded to the red one? So we have 2 different substances. So this is a mixture of 2 elements. Now here is another quick quiz for you to complete as a progress check. So this time you've got 5 statements. You need to read each of these statements carefully and decide if the overall statement is true or false. So please press pause, and then once you've had a go, hit play and we'll go through the answers together. Okay, then, so time to check your answers. Question one: neon is an unreactive element that consists of single atoms that cannot bond to other atoms, so it is a molecule. Well, if it's single atoms, it cannot be a molecule, so therefore this statement is false. Question two: carbon dioxide, CO2, is a compound because it has carbon atoms and oxygen atoms that are not bonded together. Well, this statement is, well, if you've got CO2, you have to have atoms bonded together. So therefore, this statement is actually false. Water, H2O, is a molecule and a compound because it contains 3 atoms and 2 elements chemically bonded together. Well, there are 3 atoms and there are 2 different elements, hydrogen and oxygen. So this statement is absolutely true. Question four: bronze contains tin and copper atoms that are not chemically bonded together, so it must be a compound. Well, you have to have different elements bonded together to make a compound, so this statement is false if they are not bonded together. Question five: when 2 different elements are found in a container that are not chemically bonded, then we have a compound and not a mixture. Well, again, you have to have elements bonded together, different elements bonded together to form a compound. So this statement again is false. That brings us to the end of the lesson. Thanks for watching, and I'll see you in the next one. Bye for now.